right, so in this video, we're going to quickly go over what is a polynomial and what is one of the easiest ways that we classify polynomials. So to start off, polynomials are a group or a type of function or expression. And just like all different types of function families, polynomials have their own key characteristics. So it's important for us to be able to look at a formula and be like, yep, that is a polynomial. Listed really quickly here are an example of some non-examples. These are not polynomials. They are their own function family. So logarithms, exponential equations, radical equations. These are all things that fall into our basic algebra level, different types of function families, but they are not polynomials. They are their own function families. So a polynomial is defined as an expression with one or more algebraic terms. So this definition of what is a term is actually listed here as well as in the definition. When we talk about a term, it is simply a number that is multiplied by a variable. So here it says terms, each of which consist of a constant multiplied by one or more variables. Notice that here I use the words constant, here I use the word number. That's just because constant is a really fancy way of saying number. If you look at these really quickly, variable, which we know is typically represented by a letter, is something that is able to vary. A constant doesn't vary. So a constant is just a number that has no variable attached to it. So once again, for a polynomial, it's a list of these terms. These terms are always going to be separated by addition or subtraction. So here I have an example of a few terms, 3x squared, 3x squared. Here I have a list of them. You can see that it's x squared plus 3, 3x squared minus 3. So if it's separated by addition or subtraction, then we can say, hey, it's probably a polynomial. The last bit though, see here we have two terms that are being separated by addition, but this is not a polynomial because it is inside of a square root, which we know is actually an exponent of 1/2. So in order for it to be a polynomial, the variance must be raised to a whole number power. Now we do need to add on to that a little bit. That does actually include a 0. That's really what gives us this constant. We know that if we have 3, it's really 3 times x to the 0, because x to the 0 is equal to 1 always. And so 3 times 1 is just 3. So we can't include 0. And when it says a whole number, it really means, is it positive? So these are the things that make up a polynomial if we're looking at it. So let's try and go and classify some. These immediately all look to be polynomials because they're all a list of factors. In fact, each of these has 1, 2, 3, 4 terms. Because it is a list of terms, I think I said factors earlier, I apologize. It is a list of terms, and so it looks to be a polynomial. So we have to look at those exponents. Immediately, I can see that this one has a negative exponent. So this is a non-example. This is not a polynomial. Here, 4, 2, this is really a 1. This is really x to the 0. Those are all good. 5, 3, 2, 1. Those are all whole numbers. This is good. Here, 2, 1, 0 is good, but once again, I see this 1/3. That is not a whole number, so that is not a polynomial. So this is how we can look at something and determine, is it a polynomial or not? Once you found out whether or not it's a polynomial, then you can do more analysis on it. One of the ways that we classify polynomials is actually by how many terms does it have. Each of these are a 4-term polynomial. Some of them have a slightly fancier way of saying that, and those are our basic ones. If you only have one term, such as these, notice there's no plus or minus after them, it's just one term, those are known as a monomial. Mono meaning one. By here, binomial means that there's two terms. Notice that each of these has one addition or subtraction separating those two terms. Tri means 3, so there's 3 terms to each of these. Often we see these with a quadratic like this. There's 2 plus or minuses to separate the 3 terms. If you have ones that are larger than mono, bi, or tri, then we can actually just define it by how many terms does it have. So this one has 1, 2, oops, it's missing some there. There should be a plus there, and I think a minus 8 there. Now I can see that this one has 1, 2, 3, 4, 5, so we would call it a 5-term polynomial. Often, the other way that we classify this is also about the degree. So if we look here, we know that because the highest exponent is a 2, this is quadratic. It has 3 terms, so it is a quadratic trinomial. In my next video, we'll talk a little bit more about how we can determine the degree. But this is how we can classify our polynomials once we've identified them.